It's the end of day 2 of Tech Ed. Everybody having a good time so far? You're learning a lot? Everybody saved their bandana for tonight's party? You know, during the Q&A, we have to have a quick a round of what everybody thinks the bandana is for, because I was told do not throw away the bandana. I'm actually kind of scared. I don't know what they're going to do, some sort of weird Auckland party with a bandana. But anyway, so good afternoon. My name is Dave Robinson. I'm a senior program manager on the SQL Azure team, and today we're going to be talking about database performance, but specifically database performance up in the cloud, because one of the things that we typically think about when we think about database performance is things like, how do I tune my indexes? You know, do I have the right indexes? You know, how is my server tuned? Things like that. And with SQL Azure, you know, you have to worry about some of that stuff. You don't have to worry about things like tuning the physical server, but you still have to worry about, you know, how you go ahead and tune your database. But at the same time, it is a multi-tenant system, so your databases will be living on boxes that other databases are on as well. So there's things that you can be aware of and things, you know, mechanisms that we have in place to inform you that the box you're getting on is starting to get a little hot. And at the same time, there's also mechanisms that we have inside the system to make sure that if a specific node is getting hot, you know, how we load balance that load across multiple machines in the system. So before we move forward, who is familiar with SQL Azure? Because we have a bunch of intro slides that we could either breeze through really quick or we can actually go deep. So I only see 1 or 2 people familiar with it, or maybe 3 or 4, 5. So I think that's the way of saying, you know, go quickly through the overview slides and don't bore us. So I've been on the SQL Azure team for about 3.5 years now. One of the things I get to do, it sounds like a really great job, but traveling becomes a little bit. But I get to come out here and I get to spend lots of times with people in the community, talking to them about SQL Azure, talking to them about the different workloads and the different applications that they have, and you know, whether or not they would be a fit for moving to the cloud, and if they are, how they go ahead and approach that. We had a talk earlier today around, you know, what it's like to go ahead and migrate your application to the cloud. A lot of times, you know, when we have our marketing hats on, we like to say some of these really broad-reaching statements like, just go ahead and change your connection string. And for the most part, that does work. But there are considerations that you really need to think about inside your application for getting the best performance from it. So in today's session, we're going to first go into an overview of SQL Azure. And we'll go a little bit deeper from an overview perspective, just because from a performance standpoint, it's important that you know all the different pieces in the back-end system and how they all play with one another in the SQL Azure system. Then we'll start to think about, you know, we'll talk about how you need to really approach performance in the cloud, you know, things you need to think about. And then finally, we'll talk about some of the key performance factors and things you need to think about when you have an application and the database is up in the cloud. So let's just jump in. So this is your the obligatory Windows Azure platform slide. And basically, this slide is meant to introduce you to all the different pieces and all the different building block services of the Windows Azure platform. Windows Azure platform was announced a couple years ago, and it just went live this past November. And it's comprised of the following services. Number 1 being Windows Azure. Windows Azure being your operating system of the cloud. And with it comes things like compute, storage, and management, resources that you're able to use within your application. So when you go ahead and you build a cloud application, that cloud application gets stored and it gets hosted up within Windows Azure Compute. Additionally, just like any normal operating system has, Windows Azure has a set of storage services available to your application's use as well. Things like something called a table store, a blob store, and queues. Queues are very synonymous with MSMQ. Blobs are just basically, you know, a file system for you to use up in the cloud. And Windows Azure tables, while people think of them as kind of like a database, it's a very simple way of storing key value pairs. Now, the big difference between Windows Azure tables and SQL Azure is that the amount of data that you can store within Windows Azure tables is unlimited for the most part. It's also quite less expensive than storing data up in SQL Azure. But at the same time, the things you can do with that data and the operations you can perform over that data are, you know, limited to some degree. So things like complex joins, they're not supported within Table Store. Things like, we're constantly talking about reporting services and analysis services up in the cloud. Those things will be supported on top of SQL Azure and not on top of Windows Azure Storage. Additionally, there's also a large amount of management capabilities built into the platform, and management capabilities for you to get notifications on how your application's doing. Diagnostics that you can wire into your application to say, hey, do I need to go ahead and scale up my application and use bigger compute resources or use more VMs to go ahead and host my application? So that's Windows Azure. Next to that is SQL Azure, and that's what we'll spend the rest of our time talking about today. And over to the right is something called Windows Azure Platform App Fabric. And for those of you that were in the earlier session today with Maggie that was in this room a couple minutes ago, you would have learned that App Fabric contains two distinct services. One, App Fabric connectivity, and the other one is called access control. The connectivity pieces of App Fabric are really kind of one of the coolest things that we're doing at Microsoft. And what this enables you to do, let's say you have an existing system inside your enterprise, and you don't really it's too valuable for you to move up to the cloud, but at the same time, it provides key functionality for your cloud application. What the connectivity piece and Service Bus enables you to do is actually go ahead and expose pieces of your enterprise, or services within your enterprise, expose them and have them interoperate with the cloud services and expose them securely on the internet. And additionally, we have access control, which has all sorts of STS and token-based security mechanisms for use within the platform. And then finally, we have something called Codename Dallas. Codename Dallas we announced, I think about a year ago now. And what Codename Dallas is, it's your premium information marketplace. So for those of you that perhaps are ISVs or need access to a very expensive piece of data, you can actually walk up to Dallas and get that on a pay-as-you-go model. So if you wanted to perhaps go ahead and have some sort of GPS or mapping capabilities inside your system, you can actually consume the NavTech map and geospatial database, like I said, for pennies compared to what it would cost if you were to go out and buy that on your own. Additionally, it enables you to go ahead and take the data you guys currently have inside your systems and potentially monetize that as well. So as you go ahead and you run your businesses and whatever your market is, I'm sure there's pieces of data that other people perhaps might find valuable. So Dallas gives you the ability to go ahead, put that up on the platform, and monetize it. So we say SQL Azure Database is the world's first and truly only relational database as a service. So when we say relational database as a service, it's not the relational database part, which is sexy. Well, it is sexy, but it's the as a service part that really makes it sexy. And the reason we think it makes it sexy is because you go ahead and if you need relational database resources, it's exposed as a cloud service. You don't need to worry about going out and requisitioning hardware, licenses, setting this stuff up, configuring it, and worrying about whether or not the lights stay on within this specific box. It's entirely self-managed. In a couple slides from now, we'll actually go ahead and see how we actually perform this management and how all the different building blocks within SQL Azure maintain this system at scale. We also say it's elastic scale. What that means is if you require additional resources, you just walk up to the service and you go ahead and provision those resources. You don't have to worry about over-provisioning your systems or worrying about the 2 to 3 month lead time to go get additional service in-house to handle your workloads. We also say it's developer agility. So that's a very marketing kind of word, developer agility. So what exactly does that mean? What that means is, for the most part, I'm assuming that most of the people in this room, because it is a Microsoft conference, are on the Microsoft technology stack. You're familiar with Visual Studio, you're familiar with Office, you're familiar with all the tools that we've been providing to you guys for the past 10, 15, 20 years. All those tools, everything you've learned over those past years, they all apply to SQL Azure and also to the Windows Azure platform. So when we go into the one demo that we have in a few minutes, and we walk into SQL Server Management Studio, that's a familiar tool to you. The same tooling that you're used to using with your on-premise SQL databases just works with the cloud. As we think about performance, one of the things we really need to start to think about is how your applications are architected. And I apologize if I'm boring you with some of these repeat slides for some of you that were here earlier today, but this is going to start to get really important for you to think about from a performance standpoint. When we think about how you architect your application, we see three very common patterns. And those common patterns are what we call code near, code far, and a hybrid model. Code near is when your application and your database are co-located together. This might be a SQL server on your enterprise with a middle tier, a couple of network hops away. Or it might be your application running within Windows Azure and your database is SQL Azure. The middle tier or your application doesn't have to travel very far. It doesn't have to travel over the internet to do its data access. The middle one we think about as code far, and that's your typical application where I might have a rich client app running on my PC and my database is located up in the cloud. So when we say change your connection string and move your database to SQL Azure, for the most part, that works, depending on how your application does its data access. If your application is very chatty, makes many round trips back and forth, your performance might not be as good as you would have liked. And there's things that we can actually do to go ahead and tune your applications that we'll talk about later on. And then finally, we have something called the hybrid model, which is becoming very, very popular, a very, very popular application pattern. And with this model, it's kind of like the Outlook model, where you have a local data store, and then you have your Exchange server or your other mail server up in the web. And what happens is, if you're connected, you'll be using the cloud storage. But if you're not connected, you have a local data store. And we use something called the sync framework to keep those two data stores in sync, where it takes care of all the things like synchronization, conflict resolution, and things of that nature. And this is a great model because what this enables you to do is enables your applications to always give the customer a very, very rich, peppy experience, regardless of whether or not they're connected or disconnected. One of the things that, back in the States, I have a fiber connection going to my house. I've heard many, many people over the past 3 weeks when I've been in Australia and New Zealand say to me, my customers, some of them have dial-up. Some of them have 128K connections. It's these highly latent, low bandwidth connections. It's something you need to really consider when you think about how I'm going to move my application to the cloud. So using a hybrid approach in that scenario might provide your customers with a really, really rich experience when it comes to database performance. So for those of you that are used to using traditional SQL Server or it's any database for that matter, when you think about tuning your application and your performance models, typically what that means is tuning your hardware and tuning your queries and tuning your database. So tuning hardware, Microsoft takes care of all that for you. That goes without saying. But you still need to be concerned with tuning your queries and the actual how you architect your tables and how you write your stored procedures to go ahead and do your data access. So the query performance is still very, very, very important. But then we like to say, you need to think outside the database. You need to start thinking about things like network latency and resource sharing and multi-tenancy. So what exactly does that mean? It's best if we go ahead and take a look at the overall SQL Azure architecture and how this is all put together. So if you think about it, it's shared infrastructure, it's a multi-tenant system, and it's on a massively distributed cluster with commodity hardware. So if you think about it, let's say, for instance, we have much more than 3 machines in the cluster. But let's say we'll take these 3 machines, for instance. Each one of those is running a customized version of SQL Server 2008. And on that is a specific SQL database. And within that SQL database, each one of your user databases will live in what we call a slice of that database. So that data file, that single MDF file, is shared across multiple customers. We have a scalable HA fabric, which sits there at the bottom. And all this does is it sits there and is constantly monitoring all the different nodes in the system, making sure they're healthy, making sure they're performing, making sure that your data is fully replicated across multiple machines in the cluster. At the same time, we have something we call the gateway service. And what the gateway service does is it maintains a metadata directory. And when you go ahead and you connect to SQL Azure and send it a TDS packet, or use ADO.NET to go ahead and connect, it'll actually look at those connection parameters, and it knows which one of the back-end nodes and which slice your database is being exposed in. So when we say you have a logical server with a single database, that database is actually replicated across 3 separate machines. You have 1 primary replica and 2 backup replicas. If something should happen to one of these fully redundant machines, automatically, if it's the primary, one of your backup replicas will be promoted to primary, and a secondary replica will be brought up. And if it's one of your backup replicas, it'll just go ahead and spin up another backup replica. So this is something to really keep in mind because, like I said, user DB1 is living on the same machine, same data files, DB2, DB3, and DB4. So we have lots of mechanisms we built into the system to go ahead and monitor the back end, monitor to see if the machine is under load. But this is something you need to keep in mind as you think about how you're going to go and architect and how you're going to think about moving your databases to the cloud. Since we have a small room, any questions, because this is really going to lay the foundation of the slides moving forward. Does anybody have any questions about any of this stuff here? I'm not that good of a presenter, guys. Come on. No? All right, let's move forward then. Yeah, you go ahead. I'm sorry? Go ahead. What kind of replication? It's actually a custom replication. We use a custom replication based upon WCF for the channel, and it's nothing that's available inside any of the SQL Server products today. That's not to say it's not going to be available in a future SQL Server product, but it actually works down at the lowest level of the disks to go ahead and replicate the data. Yeah, go ahead.
So the database, like my database would be in the same as your database as someone else's?
Absolutely.
And so how does the partitioning work? What about table name complex and
So all the databases are how we expose them, they're more of a logical concept than a physical concept. So it's not like you have a database and we're just, these tables are Bob's and these tables are Mike's, It's much more lower level than that. So your data, although it's existing in the same MDF file, we've built a layer on top of that to actually sufficiently silo your data, number one, and to make sure that there's no data leakage between your database and somebody else's database. We had to go through extensive and arduous, extensive security and penetration testing to make sure that this was all secure. It wasn't painful from the, hey, they're finding bugs. It was painful from just going through the process. But fortunately for Microsoft, that's something we have to go through with every release. But, before we're able to go ahead and give you guys any new service updates, we have to go through this quite a lengthy process. If we were able to just release stuff, like some of the other competitors do, just release things, we'd be able to be a bit more agile. But it's a good thing. As much as I don't like to have to go through and follow the process, that's what keeps your data secure in the Microsoft cloud. So, one last question. So there is a limit today to the number of not the number of databases, but the size of databases within SQL Azure, and that's 50 gigabytes, and that's less of a limit on the amount of disk space in these machines. It's more of a limit to let's say if your primary replica sitting on machine 5 was to go ahead and something would happen to that machine. We would have to go ahead and do a failover and spin up another backup replica for you within seconds. And so copying 50 gigs of data across the network is not the fastest thing. And we're going ahead and we're working on tuning the network and being able to offer you bigger disks. But it's not a limitation of the actual disks we use in the machines. It's a combination of the network speed. And to be honest, we need to offer you guys a certain quality of service on these databases. So if I was to get, a commodity-based server and put a terabyte worth of databases on it, what kind of performance are you going to see? There's limited, a commodity-based server has limited numbers of CPU resources and memory resources. So to be honest, if you think about, if you were able to look inside the data center, we have much more disk space on these servers than we actually use, just from making sure you have enough resources other than disk for your databases. Let's go forward. Yeah, let's. That's correct. Yeah, we don't share specific metrics as far as or specific machine types on the database, the backend nodes. So I really can't go into too many details as far as how we pack these things. The only thing I can say is, you are guaranteed a certain level of quality of service with the machine. So this is a map of the world, as everybody has, I've come to know very well traveling around. And these are the different data center locations. And before somebody raises the question and says, hey, Asia Pacific's kind of out there in the middle of nowhere, and South Central U.S. is actually in part of southern Mexico. This slide has been updated. I don't know why it's not on this deck. I'll make sure that the deck that gets pushed out to TechEd Online actually has the updated deck. The one thing I want to call out is that depending on where your clients and where your applications are located, there's potentially a large distance that they need to travel to go ahead and do their data access. So if it's a code near scenario and your application is co-located inside Windows Azure, it's not that big of a deal. If you're using a hybrid model where you have a local data store, yet again. But if you have a code far scenario, that's a pretty long distance. The other thing to think about, and we'll actually go ahead and think about how you can test this in two slides from now. But just because you might be geographically close to a certain data center, it doesn't mean that is the data center that will get you the best performance. Depending on how all the pipes and all the fiber cables and whatnot are laid throughout those big oceans of ours, you might actually get better performance if you go to, let's say, South Central U.S. I was in Africa a few months ago, and this is before we had this presentation, and I thought for sure, I'll go to Central Europe, I'll get the best performance. But actually, I was getting better performance in Chicago because I did not know that there was a fiber line between South Africa all the way up to the U.S. mainland. So we'll talk about how to test this a couple slides from now, but it's something to keep in mind when you think about where you're going to go ahead and put your application. So the first factor we like to think about is something called network latency. And network latency is the distance between the user and the application and the database. One of the calculations we like to use inside Microsoft is something saying response times is 2 times the latency of the user to the application plus the latency of the application to the database plus the query execution time. And so one of the opportunities you can use for better performance in your application is to select the data center closest to the majority of the user and leverage a code near model. But that's not always the case, as we just described a couple minutes ago in my experience inside Africa. It's something that you really need to go ahead and test. And there's also this, and I think we'll talk about this a couple slides from now, but one of the things I want to call out is there's 2 different things. There's latency and then there's bandwidth, And a lot of people, group these 2 things together, and they're actually quite different. And one of the analogy I like to talk about is driving people, taking people on a road trip in a bus. So let's say we're here in Auckland. Let's say we had to transport 100 people from Auckland to Christchurch, right? Latency is the distance between Auckland and Christchurch. Bandwidth is the number of people you can transport in a single trip. So you might have a small car, you might have a little bit of bandwidth, and you're going to have to make multiple trips back and forth to get all those people to their destination. And at the same time, you might have a bus where you can go ahead and make that trip all in one time. So these are things to think about as you're looking at your network speeds. It's not just the latency, but it's also the bandwidth that will affect your application as well. So how do you actually go ahead and measure the latency? And to do that, let me switch over to my laptop, hopefully. And let me log back in since I've been logged out. There we go. So to do that, I'm going to fire up my old friend, SQL Server Management Studio. And I'm going to go ahead and connect to a database I have in Southeast Asia. Let me go ahead and connect. So going back to the the tooling symmetry and the developer ecosystem stuff. SQL Server Management Studio, for those of you that haven't played with SQL Azure but have been using SQL Server for some time, it's the same tool, so you don't have to go ahead and learn a new tool. I'm going to go ahead and type in a new query. And I'm going to go up here to query, and I'm going to go ahead and say, include client statistics. And I'm going to do a select one. And I'm going to F5 that, and let's talk about this for a second. So the reason I'm doing a select one is that all I want to do is I want to instantiate a round trip from my client to the server and back. I don't want to have to worry about hitting a specific table. I don't want to have to worry about having anything happen on that server to go ahead and return this result to me. And now that I have client statistics on, I can actually go here, and I could scroll down, and I can actually see how long it took for that to go from here to the server and back. And that took 169 milliseconds. So for those of you that have systems in-house, depending on how your network is architected, that would be somewhere in the 10s or 20s of milliseconds if you were doing it in-house. And that's something to really keep in mind when you think about how you go ahead and choose a data center. So one of the things we recommend people to do is go ahead and do this test and do it to multiple data centers and to actually get the actual data that you require to make an informed decision around where you're going to go ahead and deploy your SQL Azure database. From a performance standpoint, a lot of times we see this. We see select one or some query, then a go, then a select one, and a go. And let's just copy that so I don't have to type anymore. We see this all the time. Microsoft is the biggest culprits of this. If you've ever used any of our tools to go ahead and generate SQL, whether it be Visual Studio or whether it be Management Studio, we do this all the time. And what this is going to cause us to do, and actually let's go ahead and just run this for a second and take a look at the client statistics. If we scroll down here and just zoom in, that just took 671 seconds of just time going back and forth to the server. And the reason being is it sent it across in 4 separate batches. It did select one, return, select one, return, select one, return, select one, return. We see lots of applications out there when people call up support and they say, hey, I just changed my connection string. My performance isn't all that good. And when we get their databases and we look at them with them, we see patterns like this. And by just going ahead and removing some of these goes, it'll go ahead and increase the performance of their query time, by orders of magnitude. And now if I go back to client statistics and just scroll over so we can actually see all of them are related to one another, we can actually see that it's gone down quite significantly. It was like I only sent one. So from an application standpoint, think about that. Think about that. When we say chattiness of application, this is one of the biggest reasons we see applications are chatty, because people, instead of going ahead and doing something in a big batch, it's just back and forth and back and forth. And when you have latencies of 176 milliseconds per round trip, that's going to start to affect the performance of your application. So it's something really, really to think about with your app. Are we back? There we are. We are back. Let's move forward. So this is a U.S. network latency. I found this on the AT&T website. And this basically, and I don't know if this kind of data is available to you guys here in New Zealand, but this actually will show you the average latency on the AT&T network from one city to another. And so as you could see, going from San Antonio to Chicago is 28 milliseconds, which is actually, it's not that bad. But it's a lot better than 170 milliseconds as we saw here a couple seconds ago. And just a little bit of trivia: Seattle to Orlando is 81 milliseconds. So I guess Microsoft doesn't like Disneyland too much, or Disney World in Orlando. But this type of data, is probably available to you based upon your network providers, and start to see if that is available to help you reason about where you go ahead and put your applications. So let's talk for a moment about resource sharing. So we said that, a gentleman asked me the question around, how many databases do you put on a machine? What is the disk space like? How does that all work? Resources are shared on all these different databases. You are sharing CPU, memory, data, log, all that stuff with your neighbors. Same thing goes for TempDB, worker threads, the procedure cache, and depending on the activity of your neighbor, you could see performance issues. Now, don't get upset yet. We're going to talk in a couple slides from now how we actually go ahead and prevent this, but it's something for you to keep in mind. But it's also, while it's something that could negatively affect your application, it's also something that you can take advantage of for yourself. And when we say take advantage of, providing multi-tenancy management inside your application. So think about things like, and it's a very common pattern, people talk about, I'm going to shard my database. The performance model of the cloud is instead of a scaling up model, it's a scaling out. It's taking the load and spreading it out across multiple machines. So when you go ahead and you use a sharding pattern, you will actually be able to take your load, spread it across multiple databases, and they will all work together for you. One of the things that, I'm not sure if there's a future slide at the end of this, but one of the things that we announced last PDC in 2009 was one of the things we're working on is auto sharding inside the database. So that way, if you have a database and it's approaching, let's say you have a 1 gig database and it's approaching the limit, you'll actually be able to type a command in and take that database and split it into 2. And SQL Azure will provide you a logical routing layer, so that way when a query comes in, it'll automatically know where to send that query. Same thing with fan-out query support and whatnot. That's something we're working on. It's not available today, but we have a lot of customers that are going ahead and implementing this pattern inside their applications today. And actually, if you go out to CodePlex, there's a couple sample projects out there for people that are actually building these generic libraries. So by scaling out your workload, you still have issues where you go ahead and you could have busy neighbors, but some of the mechanisms that we'll talk about in a moment will actually go ahead and prevent some of that. So inside SQL Azure, we have 2 things that you need to be aware of. We have a throttling service and a load balancer. And the load balancer has 2 different mechanisms. One's called a swap, and the other one's called a move. So if SQL Azure notices that a single database tenant is consuming all the resources on the box, first thing it will do is it'll go ahead and start to slow that guy up, and until the peak subsides. If after a certain period of time, after slowing this person up, there's still high resource utilization, perhaps someone has a Cartesian product or a really, really bad runaway query, we'll actually go ahead and terminate that. We'll terminate that query just to protect the other tenants on that box. And we have very detailed error messages that will go ahead and return to you based upon what happened inside the system. So we have a couple customers, 2 in fact. We have more than 2 customers, but 2 that I saw had this problem, where they went ahead and they were coding along, everything was fine, and then all of a sudden, out of nowhere, they call us up and they're like, my application was fine, but now all of a sudden I'm constantly getting this throttled. I'm always getting throttled. What happened? And what actually happened is they introduced a bug inside their system, and so the system, they had a runaway query, and the system was consistently throttling them. So one of the things we'd like to tell customers is look at these different error messages, and inside your error handling, I'm assuming everybody has some sort of generic, connection factories, inside their apps. Have some error handling to go ahead, because sometimes these error messages will tell you something about your application, not specifically something about the service. So that's throttling. We also have load balancing. So what happens if you're put on a box and somebody else, and the 2 of you, you're both the next eBay or the next Twitter, and you're the most successful application, and you're both consuming mega amounts of resources. Depending on what's going on, we're either going to go ahead and do a swap or a move. So I'm actually going to just fast forward this slide, because the build, when I moved it over to this widescreen template, just got completely whacked out and doesn't build very elegantly. But let me just talk you through what will happen here. So we have multiple machines, and on those multiple machines are multiple databases like we spoke about a little earlier. So what happens with a swap is, we talked about how you have a primary replica and you have two backup replicas. If your primary replica, which is going to be handling all the load for your system, if it's on a machine that's very busy and it's always under load, we will go ahead and do what's called a swap. And what the swap does is it takes your primary and takes one of your backup replicas that are on a less busy node, and it swaps them. And it doesn't actually swap the databases themselves. It just swaps where the transactions are being sent. That way, you're on a machine which is consuming less resources. You have more room to stretch out. At the same time, we have something similar called a move. If the swap is not successful, or if the algorithms inside the system figure out that, listen, if I just keep swapping this guy until I'm blue in the face, I'm not going to help him out. He's always going to be in a busy node because your primary and your backups are on busy nodes. It'll go ahead and do a move. So it'll go ahead and it'll create you a third backup replica. And it'll reason about where on the back-end cluster is the best spot to go ahead and put that, and put it on the least busy node. Once that backup replica has been propagated, it'll go ahead and transfer that and make that your primary, and it'll go ahead and kill which one of whether it's your primary or one of your backups that are under the most load. And it'll reason about which one really belongs to be primary, which one belongs to be a backup replica. It's coded in such a way that it knows the health of the system. If we looked earlier at the architecture and we had that fabric along the bottom, all the nodes in the system are always constantly talking to the fabric, and they're always communicating with one another to figure out, what's the health of the system, which nodes are busy, which nodes are not. All the backups today, the live backups are in the same data center as the primary. The actual backups themselves are shipped off-site. We have backups. We maintain backups of all the different pieces of the SQL Azure system for disaster recovery purposes, system failures. If it was a user error, so for instance, you walked up and you dropped your database accidentally, I know somebody in the room has done it, I have, you would have to go ahead and hopefully you would have been utilizing the database copy feature that we've just implemented to go ahead and make additional copies for user-based. We, at PDC last year when we talked about our roadmap, we talked about other features that we're working on as far as geo-replication, geo-copies. So today we have the ability to make a copy of a database, and you can copy that database to either the same server that you're on or a different server, depending on what rights you have on that server, but they need to stay within the same data center, the same geolocation. Not today, we don't. That is something we're currently working on, and that'll give you the ability to do two things. Feature number one will be the ability to go ahead and set up this geo-replicated copy and do it in a one-time fashion. So copy database foo, but put it on server in some other place, or to do what we're going to be calling a continuous copy, which actually set up a replication relationship between two separate databases in two separate geographies. So that way they'll be constantly in sync at all times. So that's something we're working on. Can't really go on record as far as saying when, but it's a feature request that we get all the time. So that's load balancing inside the system. So what are the different multi-tenancy options for your SQL Azure databases? A couple different options. Number one, using a model where you pack a bunch of different tenants into a single SQL Azure database. So why would you want to do that? People do that typically to go ahead and realize some cost savings. Because even though, let's say I have an application, and each tenant will consume 10 meg of data. If I'm going to put each one of those tenants in their own 1 gig database, that's going to cost me $10 a month for each one of my tenants. So there might be an opportunity there for you to go ahead and stick multiple tenants inside a single database and have logic inside your application to manage, which records belong to which tenants. We've seen that pattern quite a bit. And while you do see some cost savings, one of the problems that we've seen is that a customer could have a single tenant inside that one database that's very busy and will cause the other tenants inside the database to be throttled. SQL Azure can't take one of your tenants and move them. They'll only go ahead and move the entire database. So once you go ahead and put multiple tenants in a single database, it's up to you to go ahead and worry about that. And then we talked a little while ago about partitioning your workload to use more databases and to gain access to more resources. The algorithms are, and we have so many different back-end nodes inside these clusters that chances are when you go ahead and do a create database and you go ahead and do another create database, chances are those databases are going to be quite far away from one another. So if you go ahead and spin up, a couple hundred or 1,000 databases, chances are those are going to be spread out across the cluster, and they won't be competing with each other for resources. So the more databases you use, as you can read from the slide, the more I/O capacity, CPU, and memory resources you have available to that database. So if it's a really workload-intensive application, and you might not have, the requirements of storing a lot of data, you just have a lot of resource-intensive things, you might want to partition that out. I give a talk, it's up on the web, one of the tech ed sites, specifically about this, about, how to detect where your workload is and, ways to partition your workload based upon whether or not you want to partition it because you need to store more data, or if you have a really crazy workload that you want to throw at the cloud. So that's the multi-tenancy options. One of the tests that we have different performance guys on the team that all they do is performance work. Everything from tweaking disk controllers to, seeing, how far we can push a cluster. And they had ran a test, and the bottom one is the baseline, the 110 gig database. And what we saw was a 100% throughput and 100% response time because it's the baseline. But when they took that workload and they spread it across two 10 gig databases, they saw, it jump up to 228% in throughput, and the response time dropped down to 88%. Now, this is just a synthetic workload that somebody was playing with. This, like I said, it's very specific to the workload that the person was testing with. But just to give you guys, a sense of, hey, you can actually see good performance benefits if you go ahead and partition that workload. So today, like I said, it's something you need to build into your application. But we are working really hard on going ahead and providing this automatic partition facilities to you inside the service. Okay, what about monitoring and tuning? So for those of you that are familiar with SQL Server, all the DMVs that you've come to know and love, they're all there, only at the database level, not at the server level. And they work the same way that the existing SQL Server ones do. Things that are not available today are things like Profiler and DBCC. Profiler is a very, very resource-intensive product and puts a lot of stress on the system. Additionally, since, as we discussed earlier, since you're just taking up a little slice of a database, if we were to allow you to walk up with Profiler and attach it to SQL Azure, you could potentially see transactions from another customer. So right now we're in the process of doing the work to go ahead and provide you, I don't think it's going to be Profiler, but I think it's going to be a Profiler type mechanism so you can actually see what's going on inside your database. Things that are automatically available inside SQL Azure are things like corruption checks and filing and TempDB placement, file growth, things like that. Automatically handled in part of the as a service. But one of the opportunities that you can start to think about is, being able to build simple monitoring inside your system to track, your queries and how they run over time. And I don't want you to walk away from this thinking that I need to go ahead and monitor my own application. I want you to think about this a little bit differently. One of the things that we've been doing at Microsoft for a very long time is collecting usage data when you opt in. So when you install a Microsoft product, probably the first time you run it, it pops up and says, hey, would you like to, be in the customer improvement program? We'll collect, feature usage data about you anonymous, and we'll use it to enhance the products. So we actually go ahead and we use these products, and we use this data to see how people are using our applications. So one of the things you can actually think about doing is build certain mechanisms inside your software to gain insight into how people actually using your products. Which ones are the most expensive queries? Things of that nature. So you can actually start to get the data out of the system, so that way when you go ahead and you do version 2, version 3, you have a good resource available to you to figure out, hey, how is my application performing? What parts of the application are performing the best? What parts of the application are not? What parts can I go ahead and tune? Yeah, that's not something we surface today. One of the things we are thinking about is some sort of performance SLA to provide you a certain level of performance inside your database. Part of the whole cloud discussion is not having to worry about CPU and memory, but it's more worrying about, hey, make sure my application's up and make sure my application's performing. So it's a challenge for us to go ahead and say, this slice of a database is using this amount of CPU. So it's more beneficial for us to go ahead and say, hey, you know what? We will guarantee you these types of response time and these types of performance within your application. Yeah. You can't monitor CPU, but you can monitor things like bandwidth into and out of the service, and database size and things of that nature. But nothing from a resource consumption standpoint as of yet.
So if you wanted to track the log that a particular query put on the system,
You'd be using the DMVs, correct. The last factor that we'd like to talk about is something called price performance. This is kind of this is the slide that we see people when they have to make the case for moving applications to the cloud, and they have to make some sort of business case. This is the slide we typically refer people to. And the thing from a price performance is, since you don't have to go out there and provision all this hardware and buy all this software, you don't need to worry about over-provisioning or under-provisioning. The cost that you actually pay is much different than if you were to go ahead and go out and buy all this hardware. And one thing that we don't do a good enough job at Microsoft is we don't tell you how we actually charge you for the database. It's actually listed inside. If you go up to the Windows Azure and look at the pricing page, it's listed there somewhere. And I've asked them to go ahead and surface it a little bit higher up. But if you have a 1 gig database and you're paying $10 a month for, you actually only get charged per day that database exists. So that works out to being 33 cents. So we have one of the large customers. What they actually do is when they have a very cyclical work pattern of their application, and so their application will be completely silent for a period of weeks. And then they'll have a day where they'll know, oh, I have to run my month-end orders, I have to run payroll. And so what they'll actually do is they'll spin up additional SQL Azure databases, additional Windows Azure resources, just for that one day. And then they'll go ahead and they'll have a job that goes ahead and spreads out, the load inside their application. Their application already knows, hey, this customer's on this database, this payroll entry's on that database. So for the day where they're going to see a large spike in the workload, they go ahead and they spin up these additional resources. They only pay, a couple cents on the dollar for all these resources, since they're only going to live for the day. And then after that big workload spike, they actually go ahead and turn it down. Now that's a great marketing type. Oh, this is pretty picture and whatnot. Whether or not that's real world for everybody here, I don't know if that's the case. I don't know if you have, like a greenfield opportunity to go ahead and re-architect your application to go ahead and take advantage of things like that. But it's something, as we sit here and we give these presentations, this is called tech ed, right? It's to give you education. It's to help you guys. It's not to just sit up here and sell Microsoft products. I hope people watching don't, at home don't get the wrong message. But it's not. It's about helping you guys get the most out of the Microsoft products and the Microsoft technology stack. So it's things like that you can actually start to grapple and grab a hold on. So when you do have those greenfield opportunities, or you do have an application that's super expensive to run, there might be, some re-architecting work that you can do. And while, you might have to pay up front for that, over the long term of the application, it might actually you might actually be getting a better price performance inside the application. So these are some of the different customers that how are we doing on time? We have 8 minutes. So these are some of the different customers. I said Outback when I was in Australia last week, and I almost got booed off the stage. Learned very quickly that Outback is not a good, it's not a typical Australian restaurant. I apologize. But these are some of the customers that are using the platform. There's many more. If you go out to windowsazure.com/evidence, there's just tons and tons of case studies for different customers and different applications for using the SQL Azure platform. Additionally, the conversation doesn't have to end here. This is not just a one-stop presentation. The great thing about the cloud is that we're constantly, every 8 weeks, we're producing a new build, and we're giving you a new update to the service. So these are different resources that you should really think about, checking out quite often. We have the SQL Azure team blog that gets updated daily. Every day there's a new article being put out there, whether it's a scenario, whether it's a pattern, maybe it's a way to work around a specific issue. Then we have the Dev Center, which is just like every other Microsoft Dev Center. We also have something called SQL Azure Labs, and this is a really, really great site that I recommend you visit. What SQL Azure Labs enables us to do is we have kind of 2 different types of work streams at Microsoft, or within the SQL Azure team. I don't want to blanket all of Microsoft with this, but we have the production stuff that we're working on, and that finds its way into an SU. So we have a very concrete set of things that we're working on that we've gone out publicly at different events and said, oh, we're working on this and we're working on that. That is our normal pipeline. At the same time, there's innovations that we're thinking about taking to market that might provide value to you. And those innovations we put up on SQL Azure Labs. So things like the ability to go ahead and consume your SQL Azure database as an OData feed. There's an incubation out there, so you can actually perform and access SQL Azure, a SQL database over HTTP. So that's something out there. The first incarnation of our web-based version of, I always say it's the web-based version of SSMS, even though it's really aimed at a different persona. But we have a Silverlight tool up on SQL Azure Labs that enables you to go ahead and do, some basic CRUD operations and table designer stuff from your web browser against SQL Azure. Additionally, we have some synchronization stuff up there as well for setting up sync relationships between different SQL Azure databases and setting up these data hubs in the cloud. At the same time, we're on Twitter at SQL Azure. And for those of you that actually, you're not familiar with the platform and you want to get up to speed, we have the Windows Azure Platform Training Kit, which has content for all the different products on the Windows Azure platform. That's constantly being revved. Anytime we go ahead and come to events like this and we produce a hands-on lab, they find their way into that training kit as well. So if you didn't get a chance to do any hands-on labs or you want to go ahead and take some training, I would definitely recommend taking a look at that. These slides can be downloaded, or you can write down a bit.ly link, whichever's easiest for you. So that's it. I think we're down to 4 minutes, actually 3 minutes now. Let's do some Q&A, and then after, before I get kicked off, we can go someplace else, or we can just chat down here if there's anything else you guys want to chat about from a SQL Azure, from a performance standpoint, or pretty much anything about SQL Azure or Windows Azure. So any questions? There's a question right there.
Important part of the analysis, the mistakes, how
We do,
Do you do the run stats?
do we run things like query stats? And some of that is done automatically for you. Some of that is not. So if you need to recompile statistics and things like that, that's something you still need to do within your app. So there's a line that we need to draw inside the system, and that line is really, if it's at the server level, we can go ahead and do it. But if it requires things like us looking to see what your stats are like, we can't do that from a privacy perspective because typically that's your data. At Microsoft, the developer team, we're not even allowed anywhere near the production clusters. So perhaps if we were to be able to see any of your data, that's not something we can currently do in the system, even automatic. We've thought about additional services to say maybe opt in to automatically run auto statistics for me. That's something you might see on the incubation side, the SQL Azure Labs, but we would need sufficient feedback from customers on whether or not that's a valuable feature that you'd like to see in the product. Any other questions? Right here?
What's the main point then of SQL Azure? Would you say it's the ability to be able to spin up instances up and down and everything? Easy deployment processes? It doesn't seem like we get better performance or we can roll our own high availability, that sort of thing.
So high availability is built into the system. The main thing about SQL Azure is SQL Azure is a V1 product. And it's grown incredibly over the past, what are we now? We're September practically. It's grown incredibly over the last 10 months. And we're consistently adding more and more features to it. When we initially set out to handle certain workloads. Number one is ISVs. There's lots of ISVs out there, SaaS ISVs, that have these great applications that are perfect for the cloud. There's also data hub scenarios and departmental applications where you might be inside of a large company and you might need to go ahead and gain access to database resources. But the process, I've met with customers that have told me by the time they fill out a form to the time they actually get the database, weeks could go by. And that's a critical amount of time. So for a departmental application that's not going to be consuming, we're not talking running SAP on SQL Azure today. If somebody was to walk up to me and say, hey, I have this one application that runs my entire business, I'm going to go ahead and put up on SQL Azure, chances are I would try to talk you out of it. Reason being is that those are not the workloads that we've designed this for today. But at the same time, we are working extremely hard when we talk about things about performance SLAs and talk about things about guaranteeing you access to specific resources, automatic partitioning, being able to scale these databases up to limitless numbers. We're making the investments right now so that way we can start to have the conversation very shortly around those enterprise applications. So the thing we like to tell people is it's not a new technology, but it's a new platform. Take your departmental applications. Take those applications that are not, as we say inside Microsoft, take your non-tier 1 applications. Go ahead and get used to using the platform. A couple months from now, once we start to roll out some of these more enterprise class features, go ahead and move those workloads over. And also keep in mind that SQL Azure, there will never become a day SQL Azure will replace SQL Server. SQL Server is our enterprise database platform. It will always be there. SQL Azure is just another part of the SQL Server data platform for specific workload types. So, hope I answered your question. It was a kind of long-winded answer, but I hope I answered it.
So you're talking about high scaling apps, I guess, more of a deep space that can scale really fast.
That's definitely one of the workloads that we see people targeting. All right, we're out of time. I'm about to get kicked off. Thank you, everybody. If any other questions, just come on up and we can continue talking. All right, thanks, guys.